All right, welcome back everybody. At yesterday's keynote, Dario mentioned that coding sucks, and Marco is going to talk about how you can avoid some of that coding by using Design Studio and SCXML. Give it away.
Yeah, okay, so that strange effect went. So can you hear me well? Can you hear me well?
Yes.
Great. So yes, I really want to prove what Dario said yesterday. No, not really. I mean, we all know that we love coding, and all of us invest great time in providing good solutions by writing code for our customers. So that's certainly not the case. But we need to take into consideration this movement of low code, and what I'm trying to do today is just to see how that fits in the Qt world, which is not a low-code tool per definition, okay? So the title of the talk says low-code apps with Design Studio and state chart XML, okay? So as you can see already here, we are introducing a couple of Qt tools and modules that might be relevant for this kind of application, okay? So I'm Marco Piccolino. I'm a senior UI and HMI developer, been active in the Qt world, especially when it comes to Qt Quick, QML, front-end development and training as well, for a few years now. And the brand under which we provide our services called Flow-Til. We make user experiences real. It means translating what comes from a design work into actual code and applications that users can use in various settings and environments, from medical to other business application and so on. So it's cross-platform development, human-machine interfaces, and digital product design and implementation. So what we'll be talking about today, I'll start with a case study. So it is something that actually happened, a request that came from a customer, and how we had an initial understanding of that request, and how then we, with some work on our side, we got to a deeper understanding of the request, because what customers come with is usually problems, but these problems sometimes are even unexpressed or expressed in a limited way. And our first duty, I think, is to just try and get deeper into the problem and try and understand actually what the roots are and how we can provide the best solution to ease that path. That's not an easy task, because sometimes there is no money for this kind of activity, and maybe the customer, they just want to pay for the development, but still we need to include that step in every project. And then from that case study, I will ask, how can we leverage Qt in a low-code scenario, as it will present. And then I will show a few of gathered insights, so things that we discovered by playing with the Qt tools and libraries for this particular project, regarding three aspects. One is the user interface, the other one is the business logic, and finally about how to the project bootstrapping, like creating different applications for the customers and by the customers. And then we move to some final considerations. So the case study is about side channel blowers. It's a long set of words, and the point is how to make these side channel blowers smarter. What are side channel blowers, you might ask? That's a fair question to ask. And these are machines that can create either a positive or a negative pressure difference, okay? So basically, compressors are based on this kind of technology, no? When you blow like the wheels of your car or bike or so, you do have some pressure difference. This is the same kind of concept, okay? So in this case, the pressure can be either positive or negative, and it is obtained in this particular machine by the rotation of a blade, okay? And then, of course, there are several ways to control these machines. Usually it is done via inverters, which are small motors, and you just control the rotation of this blade and the direction, and you can create this pressure difference. Okay, this is a picture from not our customers. This is from Wikipedia. You can learn a bit more also. I think there is also, there is only an article in German about side channel blowers on Wikipedia, and not in English, and that really surprised me. Some kinds of applications of this machine are pneumatic transport, first of all. If you think about, for example, tube mail systems, so you have a pipe, you have to send something from here to there, and you get this air that pushes your packet to the other side, which is used like in hospitals and in big systems to move stuff around. Also industrial packaging. Then vacuum tables, so for board cutting and laser cutting. For example, when you have to cut leather, it must really be flat and adhere to your table so that you can cut over it. And you can just suck the leather to the table and make the cutting easier. Then for aeration of fish farms, ovens, swimming pools, like to get better air in those contexts, or water. And then for water and soil treatment in case there are like environmental pollution of soil or water. Okay, so a very wide range of applications and contexts. So this is the initial understanding of the customer's request. So how might we get a few custom gauges and data connectors to make our product smarter? This was like a small like summary of the request of the customers when they came to us. Okay, so we just want a couple of gauges, and we want some data connectors to be able to display this data from the side channel blower to some HMI or UI. Okay, so we went from that request and tried to get a bit deeper there by using some user experience research methods that nowadays are quite common in many projects and contexts. And this involved, for example, having interviews with a few stakeholders, that is people that work with the customer or people who work at the customers themselves, and that use the side channel blowers for several different kinds of applications and in different scenarios. Then from that, we went to user personas development, which is like identifying a couple of typical users of an application or a system with maybe different characteristics, different needs, and yeah, so sort of just writing them down. And then from that, we moved to user stories writing, which is just making an explicit list of use cases of how the people would use these applications and system when interacting with blowers. And finally, we went from that to user interaction prototyping, that is like having some quick sketches of the UI and then going a bit more by refining it. Also, again, testing it with the actual future users to make sure that we got it right. No? And this took some time, and of course, again, as I said, it's not something that is always understood by certain customers in terms of value, but it leads to a good result, and that is why you should always try and include that in your flow. This is a bit of an example of the artifacts that came out from that phase. I won't go into detail because that's usual user experience stuff. You can find a lot of it around. So a few discoveries that we made along the way. The first one regarded the deployment device support. So to what devices we should deploy the UIs. And we understood that both salespersons, technicians, and operators would be using the final applications. So very different kinds of persons and very different use cases. and very different contexts of usage. Where in one case, for example, with the operators, you are in an industrial building, and the salesperson might use the interface on a tablet just to show, look how beautiful our blower is, and it can be manipulated and controlled from a nice application. Then about rapid prototyping, because we understood that the client wanted to prototype different applications for different end customers. As I showed before, the context in which blowers are used are very, very diverse. Okay, this means that the requirements of the end customers, so the clients' clients, are very different as well. And this means that prototyping is required to get the right solution for each end customer. And finally, about low code. The client wanted to write little code because of lack of a dedicated internal development team. Okay, and this is a reality which is not so uncommon, I would say. Some of you might have experienced the same at some of your customers, no? So, getting deeper about the first point, we started reasoning about it and find out that it would be good, for example, to add support for Android tablets through Bluetooth connection, so being able to control and steer the blower from a tablet application, and then support for Linux panel PCs via a wired Modbus connection, just for the operators and industrial setting. For the rapid prototyping, we thought about creating a system for prototyping the UI very quickly on paper before moving to the actual application, and also about the creation of a themeable design system. So a design system is a set of components. We will see a bit more about it later. And themeable, in the sense that for the end customers, like the graphics, the colors, and a few other elements should have been like customizable. For the low-code part, we thought about a few more things. Supporting creators' project templates, and I'll say more about that later. Support for writing and customizing some of the business logic visually by leveraging StateChart.xml. And then finally, support for drag and drop and configurable controls and screens in Design Studio. I'll say more about all these points later, okay? So this was the initial question, if you remember that. And this turned into something like this for us, which is how might we prototype different dashboards and control panels to make our product smarter, customized for our final clients, and provided that we don't have a dedicated person or team for that yet. Okay, so this was the great limitation in this case. The limitation according to the solution that we could have provided for the customer. And the broader question for us that came out from that is how can non-developer professionals like designers, domain experts, technical roles at the customers contribute directly to digital products? One more question, should they contribute directly at all? I mean, what entitles them to do this kind of activity, and can they be actually supported so that they can do it efficiently, or should it rather be left to the experts, as we say, no? Let's take a step back and look at the low-code trend, okay? So this is a Gartner study, which is usually a sort of market trends studies, and from September 2021, and it's entitled Critical Capabilities for Enterprise Low-Code Application Platforms. Okay, so low-code is so important that now it's getting much attention from these companies that do like market trend research. The assumption in this report which is a strategic planning assumption. That is, if you want to do well in the next years, you should look at these and do something about it, okay? By 2025, 70% of new applications developed by enterprises will use low-code or no-code technologies. And importantly, up from less than 25% in 2020, okay? So big jump, like 45% in just 4 years, more or less. Of course, this is a prediction. Doesn't mean that it will be exactly like that, but it is something at least we should consider and go deeper into. Some key observations about low-code, what that entails. So the starting point, of course, is that the organizations demand custom solutions, and operational environments are rapidly changing, as Dario was mentioning yesterday. And most importantly, skilled developers are often in short supply, and we all know this too well, because those of you who do some hiring or trainings and so on know how it is hard today to get developers who are already skilled. Okay, and developer personas are becoming, for this reason, diverse. Okay, and they now include not only software engineers but also business technologists, designers, citizen developers who might develop applications for some of their very specific and very personal use cases, business analysts, and administrators. Okay, so they all sit around the table when it comes to new business applications in some capacity. And then, of course, application development frameworks should have several system capabilities, including taking care of development life cycle of software, which is more and more crucial, user experience design, development productivity, business logic and workflow, how to model business workflows, how to integrate third-party APIs, the platform ecosystem, and then governance, of course, and security and quality of service considerations as well. And finally, that customers are getting more used to pay for solutions to problems rather than for code ownership. Okay, so the wide adoption of software as a service is certainly a trend in that respect. So how can we leverage Qt in this low-code scenario? Let's focus first on the UI. And the first question is, can our, let's call them low-coder customers, prototype and implement UIs with little external support? The second question about the business logic. Can our low-code customers model their business processes and application logic as well by writing little to no code behind the UI, besides the UI? And finally, how can they bootstrap new app projects? For example, these customers wanted to create N apps from this sort of, let's say, framework, or how you want to call it. And how fast is that step as well? One more question. As developers, can we achieve these goals without writing too much code ourselves? Because, of course, new code is always a liability. It requires maintenance, and so we should really write only the code that is actually needed and that brings added value to what is already there. Now, a few gathered insights from this project, which was based on 5.14 and 5.15 versions of Qt. So things are slightly different with 6, but not so much, because actually there are not that many new models in 6. In fact, there are even a bit less right now compared to 5. And let's focus on the UI part, okay? So we started from this design system and style guide, as I was mentioning. What did this entail? It entailed creating in Figma, which is a tool for user interface designers. Very popular nowadays. Probably most of you have already heard about it in some capacity. And this entailed creating functional colors, defining them, the typography, the iconography, the user interface regions that we wanted in our final applications to be defined based on this use case of the blower, and then the controls with their states like active, disable, and so on and so forth. Okay, so you can see an example of design system here. It is basically a listing of all sorts of controls and colors and icons and states for each of these, and of course also the gauges in this case that give you some value or measure for quantities like the blade rotation frequency, the pressure, the humidity of the environment, and so on and so forth. Okay, the buttons, and that's it. And then the themes. So what is a theme basically in this case? It's the degree of variation that would be possible when theming the UI. Okay, so in this project is included by our analysis background and foreground colors, textures, shapes of background and foreground, and effects like drop shadows and that kind of stuff. So you can see an example of two different themes applied here. Forget the black background, which is just a device just to have some contrast. But you can see here, for example, that in these two cases, this is a part of the screen with a status area, action area, and monitoring area. And then here you have two different background colors. The buttons and the messages have a different a metaphor with a rounding, and also the gauges have a different background color and different foreground texture or pattern. And the buttons as well are different. Okay, so it is a limited set of things that could be changed, but this was enough to give the end customers a personalized experience that could match their brand and so on. So we developed two of these themes, but of course the point was also to be able to create more if needed with the right colors. Okay, so how did we implement controls? We leveraged Design Studio for the controls themselves and for some screen templates. So like something like this, where you can place the controls in it, and it already has some areas defined, and you just need to choose how many controls you want there and which ones, and even the buttons, how many buttons do you need, and so on. Okay. Furthermore, each component was given business relevant properties, meaning that, for example, for a gauge, you could define what is the warning level that would trigger the red color or the yellow color, okay, by just putting a value in the properties field of Design Studio, okay. So what is Design Studio? There will be a talk in the afternoon if you want to know more about the tool itself, and it's basically a glorified version of Qt Designer that is meant specifically for designers, non-coding designers. Okay? At that time, we didn't consider another product which is quite interesting, which is the Qt Bridge for Figma, which is something that, starting from a Figma design as we saw before, allows you to generate the QML code directly ready for Design Studio. Okay, so that then in Design Studio you just bind the business logic, add maybe a few more interactions or animations here and there, and you're ready to go. So at that time, the bridge was not there yet, but now it's really quite powerful, and certainly again, in the afternoon, Brooke and I think Thomas will give you some more details in the Design Studio talk about that. Oh, something happened with the... I can't go further. Thank you. Yeah. Then for implementing the themes, again, we stayed in Design Studio because we want to allow the customer to do their own thing in this limited way that I say to some parameters. And we leverage Qt's file selector mechanism to switch between themes. You can have a look at that in the documentation for file selector. It is usually used also when you, for example, you want to load just some QML files only on Android, only on iOS, only on Windows. But it can also be used for your own variables, for example, a theme, just to switch between the different graphics. And the benefit of this approach is that themes can also be edited visually in Design Studio. And the only limitation is that only the main or base theme can be applied in Design Studio itself, and then you have to preview the other themes in using a C++ runtime. Okay, I will say something more about this later. Then for the prototyping part, we basically thought about this. We had some controls that we developed in Design Studio, and we wanted to convert them to images using the grab-to-image function of QQuick items so that they could be printed out. So basically there was a script, a small project that goes through all the controls that are in the directory and that creates images from them. And for this we applied a dedicated light theme, something similar to what you can see here, so that people could actually print them out and write some stuff on that, like what kind of sensor value they would like to display, and so be quick in sketching the UI. Okay, and then once that is done on paper, then they could move to Design Studio and implement it in an actual UI visually again, as I showed before. So if we need to sort of informally self-assess the low-code maturity of this kind of solution for the UI part, I would say that rapid prototyping is there with a solution like the one we thought about, printing these controls on paper and then cutting them and just gluing them together in an interface. When it comes to composing new screens, of course, Design Studio is a great tool that allows you to really just drag and drop stuff, and it works very well. Adding new themes with the strategy that we adopted is a bit trickier because of what I said, that you could actually only modify the base theme in Design Studio, otherwise you would have to do something more to make that work for further themes visually. And adding new components is also quite easy, again, because of Design Studio's features, but then in that case the customer is left a bit alone in creating the component, and things might of course go wrong there, no? So yeah, this is a bit of a sum up of the things that I just said. The fact also that components in Design Studio are visually configurable via properties is also of course a very important value, because you can create as many properties as you want and they can represent all your business aspects, and that's easily done. Okay. Instead of using file selectors, we might next time around maybe use the custom styles, which is another technology for QtQuick controls too, and that can probably make things easier because they are supported in Design Studio. So that will give you a preview of all your themes out of the box. And then again, QtBridge for Figma certainly would be worth considering nowadays. Moving to the business logic. Now, we had a couple of cases where we had to model some complex workflows. And for example, one of these is the Bluetooth connection. Okay, Bluetooth connections are always quite tricky because there are lots of possible pairing, connection, disconnection. Was the device seen before or not, and so on and so forth. So it is a very nonlinear process, and we wanted to make easy to modify that kind of process with minimal code changes. Okay, so instead of encoding everything in code, we leverage the Qt's state chart XML framework, and the visual editor plugin that is shipped with Qt Creator. So you already have it in Qt Creator, you can just activate it if you need it. This is an example of the Bluetooth connection process. We don't need to go into details, but the point is that, as you can see, again, it's a very highly nonlinear kind of process, and there are some let's say top-level states, and then within a certain state, for example, activate the Bluetooth. You can be activating the Bluetooth, or maybe the Bluetooth is not activated, and then based on all these state transitions, you decide how to react to those, and until you reach a connected state. Okay. So the nice thing there is that a workflow like this can be represented visually, which doesn't give you so much of an advantage the first time around, because if you coded that could go equally well. But then when you have to touch it and modify it, touching the code in this case would be much more cumbersome, because of course you can have changes in several states, and you need to make sure that they are all coherent somehow. As state chart XML documents, so underneath the graphical representation there is an XML document, and this is why it's called like this. And they can either be loaded at runtime or compiled to C++ code. So even performance is not such an issue, because you can compile the state chart to C++ if needed. And you can get an overview in the documentation, and also lots of examples of various use cases. This is an example of how, entering a certain state, so we have a state machine here. When entering the activating Bluetooth state, we would do something in our Bluetooth management, let's say, library, okay, whatever that is for your specific use cases. For example, checking if the Bluetooth is enabled, and if not, then toggle it to on, and then submit an event to the state machine saying that this state we left it and we want to go to some other state. Okay, so the receiver is active. Let's do something else, whatever is represented in the chart. Another example is checking for known devices. When we enter this state in the state machine, we want to see our model of said device, whether it is 0, that is, whether there are no previously known device. Then we output this event. Otherwise, we output this other event, and then from there we move on to the next state. Okay, so it is a very compositional way of creating the logic. How then can we connect the business logic to the UI in this kind of sort of state-based approach? Here you have a QML document that represents a view, basically. And from the view, when the user does something, we have the usual signal handlers that QML provides, like onClicked. We expose the state machine to QML and submit an event to the state machine, which is like emitting a signal, more or less. Only this time it is a string, just because the state machine is a document that needs to be parsed, and so, I mean, it's not known beforehand. And then, of course, whatever changes in underlying models, which we encapsulate in things called stores, we basically react to the views in the usual like model view kind of way that you do in Qt. Okay, but then how we do visual state transitions. The state machine itself has got a signal handler and a signal which is called unreached stable state that tells you when it has entered a specific state. So it's not in a transition, but in a state. And it gives you a list of active states names. Okay, so we can bind, assign in this case, the name of the state of the XML document to the QML state of the view. Okay, as you might know, QML items have states, so you can basically give some initial state and do some visual stuff for the initial part, and then when you reach another state, then you change also the QML state that reacts to the state change in the logic. How did it go here for us on the low-code side? Connecting logic to the UI was fairly easy because of the bindings and all the goodies that we know from the Qt world, and from the way that the state machine is implemented and also exposable to QML. Simplifying existing logic, like the Bluetooth connection example, is also fairly easy because you just do need like to rewire arrows and things should work. Of course, not always, but they could work. Modifying existing logic and extending the logic is still a pain point because the customer needs to like know how to code in that case. No? If you want to add more functionality, then there is no way around it. Okay, so again, this is a sort of overview of this business logic part. Yeah, and that's it. Yes, the current state chart editor's user experience can be improved. So the tool is a basic tool and it's got the things that you would expect to get going. Of course, there are also other tools that can allow you to visually create state chart XMLs because that's a standard technology. It's not specific to the Qt world. But then again, most of them I think are commercial, and so yeah, it would be good to have probably an improved tool for that. Then, when it comes to project bootstrapping, yeah, as we saw, there were like the Android tablets, the Linux panel PCs, Bluetooth, Modbus. So, and these applications can have different sensor readings, actuators to interact with the blower. So we thought about using template wizards in Qt Creator, which allow you to customize your project when you create a new one. No? For example, you can you use wizards routinely to create new projects in Creator, no? But you can add your own steps. For example, project type in this case could be Bluetooth or inverter, which was the one that that was for the Linux panel PC with a Modbus connection. And then just the customer would choose between one of the two, and the relevant code would be created in the project for that specific use case. Okay, so things that you can customize are like, in this specific case, are things like project names, Bluetooth or Modbus based input-output, target device screen size, for example, plus the usual CMake versus QMake, Git, and so on and so forth. Okay? If you want to know more, there is documentation about project wizards. So the potential customization is very high without writing a single line of code for if you plan for it. App resource management, like managing these templates, is still a bit tricky, and on some platforms like Windows, because of long file name limitations and things like that, things can get a bit awkward sometimes. And also, like, you have to keep a couple of files in sync with the same resources, but that is probably possible to be also done with a script, so it would be less burden if you invest more time in setting it up. And some features of these template wizards have little to no official documentation, and so you have to wrap your head around it a bit and just do a couple of trials. So moving to final considerations, I have a few questions rather than answers. So the answer you have seen already based on a very specific use case and experience. The first one is, what will be Qt's place in a low-code world, the one that we are approaching? Is there a vision or a roadmap for it? I mean, are people working on Qt also thinking about this? Should they thinking about it, or should that rather be demanded to other people, some Qt users that would create solutions. I'm thinking, for example, about Felgo, no? Which is a very good example of tooling and functionality on top of what Qt provides. What about specialized Qt-based low-code solutions? What is around? Do you know any of them? Do you have any experience to bring to the table in that respect? And finally, what is your own experience with low-code Qt? Did you ever face similar situations and created something? For example, I know that I spoke some time ago with some KDAP people, and they told me for a few projects they created many custom QML interfaces, components that could be just configured, and there were also maybe logic components or like something in between the UI and the logic, and that hide all the complexity of the C++ part, and the user just combines them and just configures them and things. I mean, QML is very good for that, and not only for the UI. I mean, you could just as well create many logic APIs, just like Qt 3D, for example, does, and use them on the QML side. Python is another example. Of course, it's much easier than C++ for many people to get started. And if Python support gets better, like targeting, for example, also the mobile platforms and all Qt platforms, of course, that would be another way of enabling this kind of new customers. So thanks a lot. If you have any feedback or requests, not here, you can write to me. I'll be around until 1:30 more or less, because then I have to catch a train. Yeah, thank you.
So thank you, Marco, for the excellent presentation. Now, if you have any questions or you want to give your input to some of the questions that Marco answered, now's your chance.
One question, did you get...
Hang on a minute for the microphone, please. It's for the recording.
Recordings.
Just one question, did you get feedback from your customer? Did they experience it as an easy way to go, or is it difficult for them?
This is a very good question, and the one I was hoping nobody would pose.
Sorry.
Yeah, actually, in fact, they haven't started using it yet. Just because in this scenario, there was just 1-2 people that would take care of the project, so they wanted to get some prototyping going. Now they are waiting for the hardware part for something else. So I'm really curious about that too, because I don't think that all of this will be like used by them, but I hope that at least half of it will be used, and if that's the case, then I'll be happy. Yeah.
Is the plan that you go on working together, or is it something you give to your customer and say,
yeah, in theory it's something, we created also some documentation, and that work is not complete yet, but with documentation, some training, the hope is that they can just pick it up, and for doing the basic stuff, like doing this kind of small applications, they are completely independent.
Okay.
Yeah.
Thank you.
Hello, Marco.
Hi.
About the SCXML, you said that you have 2 ways to load and compiling.
Yeah.
In practice, what I load, hot load, and why, in which situations I compile? Because I do not visualize how I choose the better way for my application.
Yeah.
What types of application hot load, and what types of application I will compile?
Well, I can't give a definite answer, because that really depends a lot on your specific use case. But I would imagine that compiling is always good when you know your SCXML file beforehand, and it's kind of sort of set in stone, and you just use it just to manage the complexity, for example, of this kind of connection. And so you would compile in that case. If, on the other hand, you get your file dynamically from somewhere else and you want to enable that kind of behavior in some way that I cannot tell you now because it really depends, then it makes sense. Or if you are prototyping, then maybe you just load your file and start doing stuff, and then you only compile when it's needed.
Okay, thanks.
Assuming you're using Qt controls for the actual theming of the buttons, drop down and everything, do you use images exported from Figma, or is it all code?
Well, as I said, in this case, we didn't export directly from Figma. But what I noticed is that, like, the SVG export is quite good. So you could, I mean, to some extent, the Qt bridge for Figma decides itself what should be exported in SVG and what should be converted into a rectangle and so on. No, so if the default is okay, yeah, it's fine. I mean, I run also Design Studio courses, and depending on the complexity of the UI and the application, then the customer sometimes decide to rasterize more stuff, and some other times not. Depends on a lot of factors, whether the UI is scalable. And
do we have any more questions?
We find that in many applications where you have this kind of thing, these end up being embedded applications, right? Often.
yeah,
And those often have to run on very low-end hardware.
yeah.
What kind of performance implications does your approach bring with it? Because we often find that we need to optimize quite aggressively to make UIs work properly on the kind of low-end hardware that producers tend to use.
Yeah, I mean, if you really go low end, there are lots of implications about that. And in this specific case, the target hardware that we tried was Raspberry Pis, like a compute module. So quite generous in terms of performance. And I would say that if you go like to lower end hardware, that probably it is a matter of putting more constraints on what users can do with this kind of approach, so that they end up having less chances to do things wrong in terms of performance. But then again, Design Studio creates perfectly clean QML code. If you know how to use it, but the output is QML code, no, of course. Yeah, if you start but that's the same if you code manually, if you start adding many nested layers in the UI, then performance will go down. So that's a very good point, but I think you can only answer it looking at a specific use case. Yeah, same is true for Figma export. I mean, if the Figma structure is very heavy, you will get some heavy QML code as well.
Yeah, I can imagine using SVGs in a context like that is going to be a no-go.
Yeah, I mean, I know that the Qt SVG library in terms of performance is quite poor, so if you go to low end, it's better to rasterize and use file selectors maybe for different resolutions.
So if nobody else has a question, I have a question. I vaguely remember there's a thing that allows you to declaratively build state machines using QML. Have you heard of that?
Yeah.
And if you do, do you have any experience with that?
Yes, that is an alternative framework which is available in Qt. which is the Q state machine, which has two APIs. One is C++ and the other one is declarative, so with QML. I used it before. I only use it if I want to manage the state of the UI, like screen transitions, for example, things like that. If for any reason I need to keep track in what, let's say, in what screen I am, and from what screen to what screen I can go, then sometimes I use that, and it's quite convenient.
Okay, if there are no further questions, then I will thank you again, Marco. For
I
the
was
great
hoping
talk.
in a debate, but yeah.
Well, now's your chance to debate. If not, then thanks again.
Thank you.